Today we're going to talk about the third scenario where we can use the law of sines. We talked about yesterday the law of sines can be used angle, side, angle, 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 side, and then side, side, angle. And I pointed it out and we all kind of giggled. We want that to kind of stick out to us because it is a special case. So when we have side, side, angle, we have what's called the ambiguous case. And what happens in the ambiguous case is that there are three possible ways the triangle can be solved. Either it can't be solved at all, it can be solved with one solution, or there are two triangles that actually make the given information work. Okay, so what happens with the ambiguous case, and I will show you why it is the way that it is, but we can either get no solution, one solution, or two solutions for a triangle with the side-side angle given information. Okay, so how in the world can we get two solutions out of a triangle? Does that seem iffy to you? Okay, no feelings either way. All right, so here I have an image, and anything that's highlighted in blue, that's given information. So this angle right here, this side, and this side. So we have side, side, angle. And what we have to do is we have to come up with angles and a third side that would create a triangle. Okay? So there are three possible things that can happen. Okay? Here I have a triangle with an angle, a side, and a side. If the angle is big enough and the side opposite is small enough, then I am never going to get a third side to ever meet up with it. You see how that happens? Like this side, because I can't, this angle is given, I can't change it. I need to figure out how long this side is. I need to figure out what angle this is, but nothing's going to happen. I am never going to get to that third side. So this would be the case of there's no solution. And I'll show you what that would look like in your calculator. Okay? But if our angle is big enough and the side across from it is small enough, we'll never get the triangle to actually work. Okay? Now, oh, not quite yet. I don't want to make it too big yet. Okay, now here I can actually make it work, right? We have a triangle and it works. Perfect. Okay. If, well, let's make it all. Come on. So here I have a triangle, and that's the only one that I would be able to make. Okay. Where it gets tricky is when we kind of have a medium length, because watch what happens. With keeping this angle stationary and trying to figure out what angle I can make right here for our side, I can meet up right there. Nope, not quite yet. Okay, so I can meet up right there, or we can meet up right there. There are two triangles that I can make with this given information. Okay, let's talk about this. What do you think the relationship is between this angle and this angle? Those two angles right there are supplementary. Okay, so what's happening here with the log signs? We're only given one angle. So the first thing that we have to find in our calculator is an angle. And in our calculator, if we're missing an angle and we're using signs, we have to say inverse sine, and we type in a number. Okay? Well, what's true about the inverse sine? Our calculator is only going to spout off an angle between negative 90 degrees and positive 90 degrees, because that's the range of inverse sine. However, if we think about our unit circle angles, the sine ratio is positive in both the first and the second quadrant. So if I have a 30-degree angle and a 150-degree angle, they're going to have the same sine ratio. Same thing with like a 40-degree angle and a 140-degree angle. They're going to have the same sine ratio. So what we have to think about is how that is going to affect our triangle. We could have the acute 40-degree angle or the obtuse 140-degree angle in our triangle. Okay? Now, not all the time is that going to be the case because we could have just one solution. Okay? But anytime there is a side-side angle, you need to check to see if there is a second triangle. Sometimes there is, sometimes there's not. But we have to check for it. Okay? So are there any questions before we go and look at a case where we have two triangles? Okay. So what I'll ask is that you go ahead and write down this given information. And we're going to solve this triangle. So we know that A is 40 degrees, side A is 54, and side B is 62. So we can see that we have two sides and an angle that is not in between those two sides. So we have our side-side angle case. Not only does that tell us that we need to use the law of sines, but it also tells us that it's our ambiguous case. All right? So the very first thing we're going to do is find which angle. We only have one option. We have to find angle B. We have angle A and side A. We have side B, which means we need to find angle B first. So we know that the sine of angle B over side B needs to equal the sine of angle A over side A. So, how are we going to do this? We are going to multiply that 62 over. So the sine of 40 degrees over 54, we're going to multiply that by 62, okay? And then we need to solve for B. So since we have the sine of B equal to all of that, in our calculator, we need to take the inverse sine of all of that. Oh, what was it? So we have the sine of 40 divided by 54 and then multiplied by 62. $47.56. Dallas, you didn't get that? Okay. So angle B is 47.56 degrees. Okay. Now, since we have the side-side angle case, we do need to think about if there is a second triangle. Okay. The calculator gave us an acute angle that has this ratio. There also is an obtuse angle with that same ratio. How do we find it? Okay, you told me that these two are going to be supplementary. Supplementary means they would add up to be 180. So whatever you get for your very first angle in side-side angle, you're going to move over, and in your second triangle, that same angle would be 180 degrees minus that. Okay, so in our second triangle, we would have 132.44 degrees. Now, sometimes I like to show you things in your calculator to help you. Okay, have I showed you how to store numbers? Do you see this STO arrow? Okay, so what you can do is I can store that in alpha B. Okay, why would I want to do that? Well, when we come over here, to find angle C, okay, so I'm going to focus on our first triangle for a moment. If I want to find angle C, then we know we need to take 180 degrees minus 40 minus angle B. So if I store my number in alpha B, then what I can do is I can say 180 minus 40 minus alpha B, and then I don't have to type it in again. Okay, so our new angle is 92.44. And then where it really gets nice is when we go to solve our ratio. Okay, so now we need side C. Well, I am going to have to use rounded information, right? Sine of C over C equals the sine of A over A. Okay. And if you, yes? Well, no, it is not. We'll get there. We're gonna go and solve the second triangle here in a moment. But what I want to do is I want to wrap up the first triangle before we go to the second triangle. Okay. So we need to solve this proportion. Now, if you want to use the rounded answers, that's fine. I'll follow your work. If you want to avoid any rounding errors, then in your calculator you can use the exact answers. We need, it's 54 times the sine of, you can go up and highlight that so you don't have to type it in again, right? Divided by the sine of 40. Get 83.93. Okay, your calculator is very intelligent. It has some nice features to it. Whether you store answers or you use the arrow to go back up and highlight answers, use it to help you so you don't have to type things in again. Okay, so side C is 83.93. Okay, now Addison asked, is everything the same in the second triangle? Okay, our given information stays, but angle B is different, which is going to affect the rest of the triangle. So we need to go through this same process. Go with this triangle, okay? So if angle A remains as 40, but now angle B is 132.44 degrees, then when we do our 180 rule, angle C is only what? 7.56 degrees. Okay. Okay. And then for side C, we would instead set up the ratio, the sine of 7.56 degrees over C equals the sine of 40 over 54. Questions there? Or what do we get there? Anybody typing that into their calculator for me? I know what it is, but I also want you to practice your calculator so you're not at home tonight going, Addison, did you get something?
Yeah, I think it's 1.16. Yeah, I don't know.
I like this one better. Did you close your parentheses?
Yeah.
So you have 54 times the sine of 7.56, close parentheses, divided by the sine of 40. All right. Anyone else having trouble getting that? Okay. So let's just talk about the organization of this all. Okay. We had our triangle. We figured out that it was side-side angle. We found our first angle. It could be A, it could be B, it could be C. I don't know what it is, but the very first angle that you can find, that's the one we need to focus on. So whatever our first angle was, we went over here and this was the supplement, right? These are two separate triangles. The given information stayed the same and we went through the process. You need to go through the same process of finding the third angle on the third side with your second triangle, but using the different angle because that will affect the numbers. Do you see how I have my work separated into two chunks so I can clearly see what is the first triangle and clearly see what is the second triangle? Okay, I would even label it second triangle so that you can tell, I can tell, okay? And box those answers so I can pick them out. Okay. All right, well, how do we know if there's not two solutions? Is it going to be two solutions every time? No, it's not. So what is that going to look like to us if there's only one solution? Write this down and I want to show you. We have two sides and an angle that's not in between, an excluded angle. So we have our side angle case. All right? We know this is the law of sines, and we also know this is the ambiguous case, so we need to check for a second solution. Okay? Well, I have a pair of C's, so I know that the sine of 35 degrees over 314 will need to be used. And then I have side A, so we can set up the sine of angle A over 205. Okay, so remember we are going to need to multiply that 205 over, but that's what the sine of A equals. And if we're looking for the angle, then in our calculator we would need to punch an inverse sine of whatever we have on the other side. So go ahead and do that for me. please type in the ratio, multiply the 205 over, and then take the inverse sign of that. Emily, what'd you get?
21.99.
21.99 degrees. Do you agree? Anybody having trouble getting that? When we're talking about the ambiguous case, we need to right away think about that second triangle. I don't want you to forget about it. Let's just separate our work into two triangles and then go from there. Okay? Well, if we do have a second triangle, then angle A is going to be the supplement. Oh, it's going to be the supplement of angle A from our first triangle. What would that equal? 158.01, right? Thoughts? Why is it too big? Okay, this angle plus our original angle, 35, is already more than 180 degrees. There can only be 180 degrees in a triangle, and we're not about to have negative angles in a triangle. That doesn't make sense. So, this is not going to work because the angle is too big, and we only have one solution. We have one solution where our angle A is 21.99. And then we can find the rest from there. Angle B, if we take 35 plus angle A and subtract it from 180, would be 123.01. And then we can use that information to find side B. Our other two sides are pretty big. Angle B is the biggest angle by quite a bit, so side B should be significantly bigger than the second two. What do you got for me? Good. Okay. You always want to think about if your triangle makes sense. Our smallest angle is across from our smallest side. Our biggest angle is across from our biggest side. And if our biggest angle is significantly bigger than the other two, then your side across from it is going to be significantly bigger than the other two sides. Okay. Just keep in mind that it is always the first angle you solve for that you take the supplement of to find your second triangle. If that angle is too big, there's not a second triangle and you only have one solution. Okay, but you need to check for it. What do you think about a problem like this and the number of points it's worth compared to a problem from yesterday's notes? Is this one going to be worth the same amount of points on a quiz test or more? Probably more because there's more work. If you don't check for that second triangle, you lose half the points of the problem. Okay? All right, last example. What haven't we talked about? We haven't talked about the no solution case. Okay, when our angle's too big and our side is too small to meet up with the third side. Okay, so first notice that we have two sides and an excluded angle, so side-side angle, which tells us we're using the law of sines, and it is the ambiguous case. All right? If we go to set up this problem, we have the sine of 30 degrees over 2 equals the sine of b over 6. So we can multiply that 6 over. I want everybody to punch this into their calculator. We have the inverse sine of, our ratio was the sine of 30 divided by 2, and then we multiplied 6 over, correct? What? A domain error. Okay? That's because, what's the sine of 130, or what's the sine of 30 degrees? 1/2 times 6 is, so this is 3/2 right here. And we know that sine has to be between -1 and 1. We're getting a domain error. Well, it's the easiest thing to do because that just means we have no solution. You can't find any angles or sides because they can't exist. So if you get a calculator error in a side-side angle problem, there's no solution, and you're done. Okay. Out of a class of 24, only 11 of us made the Homework Heroes board. While I am very happy for those 11 people, the rest of us need to step up our game in this next chapter. Chapter 5, and I told you right away, if you don't do your homework, it's going to be rough. And some of you found that out the hard way. Please keep up with your homework. You are not going to remember this ambiguous case and how it works unless you do your homework tonight and practice it. If you don't understand the process that you're doing to get the answers, then you have to speak up. I can't read your mind. Okay? So make sure you communicate after your homework if there are any issues. Okay?